Hello, today we're going to learn how to solve. So this is the solution procedure. We're going to find the solution of a second order linear homogeneous recurrence relations. And basically what we're going to do, we're going to use a method to solve this. This is called the characteristic root method. So let's start. So first of all, what is let me recall what is second order linear homogeneous recurrence relations. So if we have a sequence and if the nth term of the sequence an can be written as a real number c1 into the an minus 1th term plus c2 into an minus 2, and c2 is non-zero, and this is start from n greater than equals to 3, and also the value of a1 and a2 are given. So on that case we will say that this is our second order linear homogeneous recurrence relation. So this is our second order linear homogeneous recurrence relations, and if a1 and a2 will be given, they are the initial value of the sequence, or you can say that initial value of the recurrence relations. So we're going to find a method to solve this equation. Solve means we have to find an and some function of f. So we have to find something like that, only on function on n, not in this form. So this is already given, so we have to find by this method. So what we're going to do, so let me first erase this first. So here is the procedure. So what we're going to do, so we're going to write the equations in this form. So rewrite the equation. So rewrite the equation in this form: an minus c1 an minus 1 minus c2 an minus 2 equal to 0. So first rewrite the given recurrence relation in this form. So next what we're going to do, we're going to put the value x square instead of a to the power n. So the characteristic equations, so that's why it is the name characteristic root method. So characteristic equations of sorry again for my handwriting. So characteristic equation of the above recurrence relation is, what we're going to do, at the position of an we're going to write x square minus c1, at the position of an minus 1 we write x, and at the position of n minus 2 we just put 1. So c2 into 1 equals to 0. So this is our characteristics equation. So you can see that this is a second order polynomial equations in x. So we can find the value of x. So we have two roots. If we solve this polynomial equations, we can find the two roots. So if we find two roots, x equals to x1 and x2 are two roots of the equation, two roots of the above polynomial equation. So of the two roots of the equation x square minus c1x minus c2 equals to 0. If we have find two solution x1 and x2 of this equation, so what we're going to do, so we're going to write the general solutions. So here we have two possibilities. So let me erase this first. So if we find the two roots of the equation, so here have two possibilities. So case 1 and case 2. So case 1 is if x1 and x2. So if x1 and x2 are different, then the solution an of the equation will be some constant capital A into x1 to the power n plus some constant b into x2 to the power n. So a and b are constants. So what we are going to do, so a and b are here, where a and b are constant, so they are constant only. So what are we going to do, how to find the particular value of a and b? So this is our solution, this is the general solution, because it's a general term. So general solution of the recurrence relations. So now how to find a and b? So it's always given the value of a naught. So if we start with n equals to 0, so a naught, maybe a naught will also be given, and also n1 will be given. If I start from n equals to 0, if we start from, suppose instead of, if we also forget about that, if we have given the initial term a1 and a2, we form that initial term, we can find the general solution. If the initial term start from a naught and a1, then we can find from initial solution the particular value of a and b. And if the initial term starts from a1, and if a1 and a2 are given, so from there also we can find the general solution. We will see that in some examples. So this is case 1, and case 2 is, so just do not want to erase this part. So case 2 is, there is only one possibility left. So x1 equals to x2. If x1 equals to x2, then general solution will be n equals to a plus b into n x to the power n, where x1 equals to x2 is, we assume that this is x. So if we will find the value of x, and actually the x is basically x1 and x2, because they are same, so we have only one value x. So general solution will be an equals to a plus b into n into x to the power n, again a and b. So here similarly, where the capital A and capital B are constant, that can be reduced, that can be find out, we can find that out from our initial conditions. So let's solve some problem. So first let me erase this first. So I hope you are all right and doing your homework, and if you have any problem, just comment me below about, if you have obviously about any problem regarding my course, then please comment it below. So let me start with some equations. So suppose we have an equation like this. So suppose you have to solve the equation. So solve by characteristic root method. Solve by characteristic root method. So characteristic root method, because we find the roots from the characteristic equations of the recurrence relation, that's why it's named characteristics root method. So solve by characteristics. So sorry, again I just forget the 3 words, sticks root method. So characteristic root method by the following equation. Suppose we have the equations an equals to the Fibonacci sequence. So n equals to an minus 1 plus an minus 2, and here we have the initial condition a1 is 1 and also a2 is 1 over here. So what we're going to do, we're going to find the general solution, so general value of this Fibonacci recurrence relation. So Fibonacci recurrence relations is one of the example of second order linear recurrence, homogeneous recurrence relation. So what we're going to do, so this is our solution procedure. Solution. So here we use some different ink. So we have the equation an, so rewrite the equation, we get an minus 1 minus an minus 2 equals to 0. So in this equation, so if we put over here, so characteristic equation, so characteristic equation is, so what we going to do, we write, so it was x square minus c1x minus c2 equals to 0. So now here in this equation, what is c1? So here we have general equation an minus c1 an minus 1 minus c2 an minus 2 equals to 0. Now we have over here an minus 1 minus an minus 2. So if we compare this equation with our Fibonacci equation, so we will find that c1 equals to 1 and also c2 equals to 1. So our characteristic equation becomes x1 minus x minus 1 equals to 0. So here we have this equation. So what will be the root of this equation? So we're going to use the Siddharacharya theorem. So after using the Siddharacharya, we get x equals to minus of minus 1, so it's a minus b plus minus root over minus b square minus 4 into a into c by 2 into a. So we get 1 plus minus, so we get root 5, so 1, so here we get plus 4, so 1 plus 4 5 by 2. So here we get two different root, x1 is 1 plus root 5 by 2 and x2 is 1 minus root 5 by 2. So we get two different roots of these characteristic equations. So from there, so we're going to, so if I use the root methods, general solution will be, so first let me erase this first. So general solution is, so here we go, so general solution is an equals to x1 a x1 to the power n plus b x2 to the power n, where a and b are constant. So a, what is x1? 1 plus root 5 by 2 whole to the power n plus b into 1 minus root 5 by 2 whole to the power n. So this is our general solution. So what it is given now, that we have the value a1 is 1 and a2 is 1. If I put that value, so if I put n equals to 1, so what we get a1 over here, because n is 1 over here, a into 1 plus root 5 by 2 plus b into 1 minus root 5 by 2. Now put the value of a1, so a1 is 1 over here, so we have 1 into 1 equals to a plus 1 plus root 5 by 2 plus b into 1 minus root 5 by 2. So we get one equation. So if I put n equals to 2, we get another solution, another equation. So for n equals to 2, so what we have? We have a2 equals to a into 1 plus root 5 by 2 whole square plus b into 1 minus root 5 by 2 whole square. So now a2 is given, a2 is 1, so we just put 1 into a. So now find the value of 1 plus root 5 by 2 whole square. So it gives, here we have 4, and here we get 1 plus 2 root 5 plus 5. So 6 plus 2 root 5 by 4. So it gives actually 3 plus root 5 by 2. So just let me write the 3 plus, we get 3 plus root 5 by 2. So just let me erase this. Another one will be 3 minus root 5 by 2. So I ask you, just pause the video and do the calculation by yourself. So here we get 3 plus root 5 by 2, and here we will be get 3 minus root 5 by 2. So here we have another equation 1 and 2. So if we solve these two equations, we will find the solution of two equations. So if you can you find the solution? So after finding the solution, we will find the general solution of the equation. So if I do this, so what we get till now? So just let me write that down. So what we going to do? We're going to just write it down as erase the above parts. So what we get, or I just thinking about, just left to you to find the equation. There are only two solutions, so you can find it out, I hope. So I just let me rewrite the equations in more easier form, then I will left to you. So a 1 plus root 5 by 2 plus b into 1 minus root 5 by 2 equal to 1, and this is our equation 1. And here we have equation a 3 by 2 plus root 5 by 2. Actually if 3 plus, so it's something like that. So plus b will be 3 by 2 minus root 3 root 5 by 2. It gives us 1. So 1 and 2. So if I solve these two equations, what we get from now, you have to just comment me below. So please comment after solving these two equations. So can I do it, or I just left for you? If you I first just left it to you. If you have any problem, just comment me below, then I will solve the equations and told you to that. So thank you for watching.